My name is Dave Tenenbaum. I'm going to be your tour guide today as we learn about a flavor of artificial intelligence called deep learning. I have a master's degree from MIT. After graduating, I got seduced into becoming a photojournalist and ran around shooting pictures of presidents and popes and wars and space missions, Super Bowls, and it was all about high-impact visual storytelling. Then I founded MerlinOne to help people who have large quantities of photos, videos, Microsoft Office, and other digital files find just the right one to use and hopefully not go insane in the process. Once a decade, a new technology shows up that lets us really do a leap in the capabilities of these digital asset management systems. I live for those times, and this is one of them. It's all about deep learning. There are two compelling reasons to know about deep learning. First, while there's a lot of hype out there, it really is likely to improve your work life significantly. The second reason was spelled out by Mark Cuban last month. Understand it or get left behind. We don't want that to happen to any of you, so hang in there for the next few minutes and maybe we can have some fun with deep learning. Deep learning is where you teach a system to know about something, then put it to work doing something useful for you. Till now, the only way you've been able to search is on text, and frequently, the only thing you know about a given picture is its file name and the date it was taken. If you're really lucky, somebody had to sit down and type in metadata, like a caption or what city it is or the project name, all manually done. Because after all, computers can only search against the text. They can't see the pixels in the images. Or maybe now they can. We're going to look at three new capabilities that were essentially impossible a few years ago. Maybe we can find some magic. We've all seen facial recognition on TV shows. Let's see what it's like in real life. It breaks down into two problems. First problem is, how do we find if there are any faces in this image? If there are no faces, our work is done. We don't have to do anything. The second problem is, we've found a face. How do we mathematically code that face so it becomes what you might call a face print, just like a unique thumbprint? First problem is how to detect a face. And if you look at the larger image with a very crude outline of a face, we run a mathematical operation with the inelegant name of HOG. And you can see on the left side, the eyes, nose, and mouth become much more apparent. And it turns out this is a really good way to identify if there are any faces in an image. How well does it work? Well, if you look in the green box on the top right, you can see in very deep shadow a face. So it's done a great job finding even an obscure face in that image. In this example in the green box, you can see a face that's detected even though it's partially obscured by somebody's arm. So problem one is solved. We can detect faces. Let's move on to problem two. Okay, we found a face. Now what? Here's a picture of Prince Harry at his royal wedding, and we need to use another set of deep learning algorithms to create a digital thumbprint, a unique numeric identifier of his face, and it ends up being something like 500 numbers. The use case is, you work at a hospital and you've got 1,000 pictures from a fundraising event last night, and you need photos of your star oncologists with big fundraisers. Until now, you had to go through the pictures one at a time and type in their IDs in order to find what you're looking for. But with facial recognition, you could go to one photo that shows your star oncologist, type in her name, and it will instantly go out and find every other time that face appears in any of the 1,000 pictures. Here's the picture of Prince Harry that we tagged, and the computer has returned to us neighboring pictures of that point that it feels probably also are Prince Harry. They include pictures of him in a military hat with a full beard, looking left, looking right, different facial expressions, different emotional content. Here he is clean-shaven in formal wear. In his younger days. And this all happened pretty much instantaneously. With one operation, we saved hours and hours of work, and all we have to do is confirm, yep, these all look like Prince Harry to us. And you can flip to our use case where we were looking for pictures of our star oncologist. Obviously, you could apply the same thing there and save an enormous amount of work. That is pretty good magic. Okay, let's move on to something else that was impossible until recently. We've got 250,000 pictures in our collection, and someplace in there we think there's a picture of someone on a hot day going through a sprinkler to cool off. But we don't want to go through 250,000 pictures one at a time to find it. We did early on come across a picture of this fellow in a swimming pool splashing water, and it occurred to us, I wonder if these water droplets, if we could find a system that could return to us pictures that look like this, maybe we would get our sprinkler picture. How would we do that? Instead of a thumbprint of a face, we could take a thumbprint of the whole picture and put all the thumbprints of all the pictures in that 3D space, like facial recognition, and let AI sort them into clusters of similar images. Then let's ask it what neighbors exist around this picture, and how about we see what we get? And the visual similarity search returned. The model saw one type of splashy water and returned to us everything similar, and we can use one of the two lower left pictures for our project. Think of the time it saved us. It found these in 250,000 images in 25 milliseconds. How long would it have taken any of us to go through all these images one at a time until you found what you needed? Hours? Days? Personally, I'd never make it through. This is another example of things that were never before possible. A computer actually seeing and understanding images. That's an amazing new capability. Here's our third case, finding the most impactful image. Way back in the day, as a photojournalist, we were taught that we had 1/4 of a second to capture a reader's eye before they flipped the page in a newspaper. Photo editors learned after seeing thousands of images which ones would arrest a reader and which would get skipped over. What if you're agonizing over which image from a photo shoot is really the best? Would it be useful to have a deep learning model trained by world-class editors to score your candidate images for you, just to give you another data point in your decision-making? You assign a shoot of a young couple for a campaign you're planning. You get back dozens of images. Which do you pick? Now let me be upfront and say that photo editing is of course highly subjective. But having said that, here are the top 5 images a model trained by professional photo editors selected. And to round out the picture, here are the bottom 5 scoring images from the shoot. Pretty amazing. Again, never before possible. Hopefully we've demystified deep learning a little bit, and we've seen 3 examples where deep learning might improve your work life. AI tools are going to change your world, and they're coming quickly. Pretty much everything you saw in this presentation was simply impossible a few years ago. Any questions? Feel free to reach out to me, and thanks for your time.